Right, this is going to take you through the graph drawing for advanced higher physics. First thing you need to do is to make a copy of what you've got there. So I'm going to make this copy 3 of advanced higher physics, and going to put that in a drive location that is obviously easy enough to find. Right, the data that you've got here is actually a repeat results of what we had for the higher. So although there's only 3 repeats shown, it would obviously be at advanced higher more sensible to do 5 trials rather than 3. I'm going to take you through calculating approximate random mean uncertainties, displaying the error bars on the line graph, and then calculating the gradient and uncertainty in the gradient using LINEST. So first thing is to calculate the mean of the irradiances. So if we put in average, and the easiest thing is just to sweep through all 3 cells there, press return, and that will give an average value there, which can then be copied down by clicking on the bottom right where you get the small cross, drag that through, and that's the averages for all those results. We also need the 1 over d squared, so 1 divided by d times d again, close the brackets, return, and copy that all the way down. What you can do is, once you've got all the top line, is you could copy all 3 down. The approximate random mean uncertainty, that's going to be equal to, with open brackets, then you're going to use the maximum function of this range of cells here, close the brackets, minus the minimum of the 3 readings there, close brackets, then close the first set of brackets, and then divide that by 3 for the number of readings. And again, those approximate random mean uncertainties, they can be copied all the way down the table there. Now, because they vary, what we'll do is just get an average of those. So if we get average, the brackets, and that'll give an average of all those, which is that 0.10 is what we can use for the error bars in the line graph that we're going to plot. So to plot the graph, because the 2 columns are not set up the way that we would want them for x and y, the easiest thing to do is to highlight the y data. So we want irradiance on the y-axis, and we're going to insert a chart. And that will at first give the default sort of bar chart that Excel and Google Sheets resort to. We're going to change that to a scatter chart, scatter graph, just in there. And we're going to change the x-axis here to put in the data for the x, which is going to be from cell F1 to F10, and that will be all the 1 over d squareds. And now we've got a graph that looks a little bit more familiar there. So it's time to customize that, just as we did before. Don't really need to change anything to do with the background color. The titles, we do need a title for the horizontal axis. That hasn't come out there, so we'll put in inverse square of distance, and that's going to be in watts meters minus 2. So that will go along with that. It's minus 2. Okay, so that's in series that we're going to do most of the work here again. So we'll change the color of the points to black so they come out clearer when printed. Change the size to 2 pixels because the SQA quite clear that your points must be clear enough to see what's going on the grid. We are going to put in error bars, and to do that we're going to use a constant value, and this is where the 0.1 that we calculated as an average comes in. Don't need data labels, but the trend line, the best fit line, we can keep the linear option that's given, check that that's on black, and the opacity will change to 100%, so it's clearer when printed, but change it to a narrower line, so again it's clearer to see whether it goes through the error bars or not. Legend, we're not going to have to change anything with, but the horizontal axis, again, that minimum value isn't on 0, so we'll change that to 0, and everything else is okay. So the vertical axis doesn't need change, but the grid lines, again, the vertical axis could do with more major grid lines, and certainly 10 minor grid lines. Horizontal axis, again, minor grid lines. So your graph there now is fine to open up in its own sheet, and that will give the, if you now copy that in using copy chart at the top there, that will give you the best detail in any print that you have from that, provided the page is landscape. So last thing is to get the gradient and the uncertainty in the gradient using LINEST. Just even up these cells a little bit here. We're going to put the LINEST array in starting at cell J3. So in cell J3, if we say equals LINEST, open the, now you start off with all your Y values, so that's from cell E2 all the way through to E10, type a comma, and then highlight all the Y values. So it's going to be F2 to F10, and then you type in true, comma, true, these two Boolean values. Just set the statistics functions in LINEST, pressing return, and that will then give you all this data here. The bottom three rows we're not interested in at advanced higher level. You can read up on them if you want, but it's these two here, the gradient, the uncertainty in the gradient, and the y-intercept and the uncertainty in the y-intercept. So if we go back to the actual instruction document, that's the way that the results should be pasted into a project report showing where you're getting this data from LINEST. So that's giving us a value of the constant in the equation I over k, I equals k over d squared is k equals 0.359 plus or minus 0.008 watts. And because the original data was more to two significant figures than three, we'll change that to k equals 0.36 plus or minus 0.1 watts. And that's our uncertainty in the gradient of the graph, but not obviously the combined uncertainty that you might be looking for otherwise. So approximate random mean, the error bars, and LINEST for advanced higher physics.